Hello everyone, this is Math Science and Beyond. Today we are going to look at this question and I'll try as much as possible to see how we want to solve it in such a way that we will not need the use of what calculator. So that's the essence. So let's start. Now, this is 2 2 raised to power 11 plus 4 raised to power 11 plus 8 raised to power 11 all over 8 raised to power 11 minus 1. So what we are going to do is that we will try and transform 4 and what 8. 2 is there already. There is nothing you can do to 2. But we will try and transform 8 and 4. We know that 4 is equal to 2 times 2, which is the same thing as 2 raised to power 2. We also know that 8 is equal to what? 2 times 2 times 2, which is the same thing as 2 raised to power what? 3. So instead of 4 here now, we are going to substitute 2 raised to power 2. Instead of 8, we are going to put 2 raised to power 3. So let's go. So in that case, that means the problems becomes 2 raised to power 11 plus 2 raised to power 2 raised to power 11 plus 2 raised to power 3 raised to power 11 all over 2 raised to power 3 raised to power 11 minus 1. So at this stage now, what we are going to do is that we are going to rewrite the whole thing. So how do we do that? We'll do 2 raised to power 11 plus 2 raised to power 11. We want 2 raised to power 11 to be inside the bracket. This is the same thing because when you have in indices, when you have a raised to power m into n, you can write it as a raised to power n into n. So the 2 goes. So the next thing is plus 2 raised to power 11 raised to power 3 all over 2 raised to power 11 raised to power 3 minus 1. So what we are going to do next is that we are going to represent 2 raised to power 11 with something. So let 2 raised to power 11 be, you can use it, you can use a letter for it, any letter of your choice. Let's assume we are using letter S. So in that case, that means when we substitute, that means we are going to substitute S for 2 raised to power 11. Anywhere we see 2 raised to power 11, we are going to substitute S. So therefore, the problem becomes S, sorry, let me shift my hand, S plus S squared plus S raised to power 3 all over what? S raised to power 3 minus 1. So this is what we have transformed the whole thing to now. So the next thing is that we will look at, if you look at the numerator S is common in on the numerator, and if you look at the denominator, you will see that this is what we have there is called difference of what? Difference of 2 cube. So in that case, what we are going to do is that for the numerator, factor S out. So if we factor S out at the numerator, what are we going to have? We are going to have S into, we have 1 plus S plus s squared. Do you understand? So because if you multiply it out, now you will see that s times 1 is s, then s times s is s squared, then s times s squared is what? S cubed, s raised to power 3. Do you get that? So the next thing, for the numerator, factorize using what? Difference of two squares, two cubes, sorry. So what are we going to do there now? That means this numerator, which is s cubed minus 1, we'll represent it as this minus b cubed. And for us to be able to factor this out, this is the same thing as a minus b, then I hope you are seeing it, a plus ab. Let me rewrite this, sorry. So this is going to be equivalent to a cube minus b cube. So if you want to factor this is how to go about it. A minus b into brackets a squared plus b plus ab plus b squared. This is how to factorize difference of two cubes. So in that case now, the next thing we need to do is that we know that, but in this case, a is equal to s and b is equal to what? 1. So if that is the case, that means anywhere we see a here, we are going to put s. Anywhere we see b, we are going to put 1. So in that case, we'll say s cubed minus 1 is equal to s, this is what we are doing now, s minus 1, then we open brackets, we have s squared plus s times 1 plus b squared. B squared is what? The b squared, that's 1 squared. So in that case, this becomes s minus 1, s squared plus s plus what? 1. Because when you multiply s by 1, you will see that it's going to give you s, and when you do 1 squared is going to give you 1. So in that case, we'll bring the numerator and the denominator together. Therefore, we will have what? If you look at it, this is the numerator, which is s into 1 plus s squared, all over, this is the denominator, s minus 1, s squared plus s plus what? 1. Now, if you look at the numerator, you will see that we have 1 plus s squared. And if you look at the denominator, you will see that we have the same thing here. It's just that the arrangement is different. But since it is addition that is binding all of them together, so this is, if you read it from here, it's going to be 1 plus s plus what? S squared. 1 plus s squared. So therefore, this can be cancelled. Is that okay? So in that case, we will be left with what? S all over s minus 1. But don't let us forget that we actually represented s with something. I mean, something with s. So we will now go back at this point here. So what we are going to do now is that, let me clean this. So let's come here. At this stage, we have s all over s minus 1. So at this stage now, we will now say, but s is equal to 2 raised to the power 11. Therefore, by substitution, we have let's look at this. Now we are going to replace s with 2 raised to the power 11 back. So 2 raised to the power 11 all over what? 2 raised to the power 11 minus 1. So if you look at this, for you to be able to get this rightly, what you are going to do is, if you look at it, if you say 2 raised to the power 5 is 32, and another 2 raised to the power 5 is 32. So if you multiply them together, what will you get? You are going to get 4, 2 times 3, 6, 9. So if you look at this, you are going to get 1024. So 1024, if you multiply it by another 2, because we still have 1, 2 left, this we have succeeded in using 5 and 5 again. So 2 raised to the power 5 in 2 places, that's 2 raised to the power 10. So if you do it like this, that means it's remaining the 1, 2 that I have not used. So 2 times 4, 8, 2 times 2, 4, 2 times 0, 0, 2 times 1, 2. So what we are going to have here is going to be 2048 all over. You are going to have 2 raised to the power 11 is 2048, right? But we have minus 1 here, minus 1. Therefore, our result is going to give 2048 all over 2047, because we have subtracted 1 from here. So this is our final answer. Kindly share, like, and comment. Thank you.